All right, so here's one of this is still the same picture from last time, I haven't entered yet, but here's one of the functions that Pharaoh studied. E to the ix plus 1/2 e to the 6ix plus 1/3 e to the negative 14ix.
Whoa.
Whoa.
See. Ooh, interesting.
We're still going around 200 times.
Yeah, let's go around 20 times.
Oh, just because
So the lines are
thinner.
sort of like a pentagon, but you have those loopy fish things in the middle.
Okay, so where do you think, or what does this remind you of?
It's like a 5-pointed star.
Interesting.
I think it has 5-fold symmetry.
Huh.
So if you drew.
How about you? What do you think?
Well, yeah, this sort of look like a pentagon, and you have these on every side, and then, so I'm not sure how you would fold it 5 ways.
Well, maybe if you drew lines from the tips down to the origin, and then cut along the lines, you would get 5 equal pieces.
Fascinating. Do you see why this reminded me a little bit of the loop-de-loops?
Oh yeah, they're like unpixelated loop-de-loops.
Yeah.
You have loopy patterns.
They're kind of like the spirographs.
Yeah. Yeah. So one of the surprises in this is, where does the 5 come from? So we've got e to the ix, 6ix, and minus 14ix. So where in the world did the 5 come from?
There's no real 5s.
So this is what really surprised me when I saw an article. Actually, our friend Evelyn Lamb wrote about this. I was really surprised. But when I read the book, I learned how you can make other ones. Like I can make one that has 7-fold symmetry here. Now that I know what to do. Let's make that a 9, and let's make that a minus 13. How's that sound?
Alright.
Okay. Ooh, interesting.
Doesn't look like it has 7-fold symmetry, though.
Yes, because I need it to be 12, actually. I forgot how to subtract 1 or 2. There.
There, 7-fold.
So what do you think about that? Does that have
That has
7?
7-fold symmetry.
So the same thing is kind of mysterious here. 2, 9, and 12 produced 7 somehow.
We don't have any 7s.
We don't have any 7s. We don't have anything that even looks like a 7.
Well, what if you like expanded it? What if you made this number like bigger?
Which number?
The 20.
What would you like to make it? 40?
Let's make it 40 and see.
I think the lines just get thicker. You're just going around a few times.
Yeah. What, would you like to change something here?
Maybe we can make this. Let's see. Maybe 3x.
Okay.
Let's 7x there.
Okay.
And maybe minus 15x.
Alright.
I'm not sure what this is gonna do. Ooh. I think it has 4-fold symmetry.
Pretty interesting. It seems to be symmetric on the real axis and on the imaginary
Looks
axis.
like a 6 there.
Do you see any other symmetries here?
No.
If you fold it maybe along this axis, the diagonals too. Doesn't really look like it though.
Yeah, it seems close, but it's pretty amazing that you can get this
Shape.
fascinating little shape just from changing a few of the numbers. Do you want to try?
Okay.
Try some changes? What would you like to see?
How about if we did 3... How about we did 4x?
Okay.
4... So... No, like... How about we did 11 here?
Okay.
And how about... Instead of 15, we did 9. Or how about actually 13?
Okay. You can also change the coefficients on the outside, 1 1/2 and 1/3. But let's take a look at this now.
Doesn't really look like.
This looks, well, actually, if you cut it here, along here, it looks symmetrical.
Fascinating.
Wow.
So in these all by themselves, we saw were just circles, right?
Yeah. But
Like I
then
can
you
cut that and I just get a circle.
But then you can.
When I put it back in, these other circles, this would be a circle. This part would be a circle. But they're being drawn differently and drawn at different speeds, and then when you add all those things together, you get these amazing shapes. And that's what Ferris, that's one of the things that he's talking about in this book. And you saw some of the pictures in his book, right?
Yeah.
And they're really cool. Alright, so what do you guys think about this?
It's pretty cool.
Yeah.
Alright, do you want to play around with it a bit more?
Sure.
Okay. I'm going to turn the camera off, but you guys can play for as long as you want.
Okay.